exponential equation. An exponential equation is an equation that has a variable as the exponent. So, for example, if I were to have 3 to the power of x equals 9, this is an equation because it has an equal sign. We would be solving for x, and then more specifically, the x, or the variable, is the exponent. So we would be trying to figure out, okay, well, 3 to what power equals 9, and then that's an exponential equation. Pro tip, remember that equals means that both sides of the equation are the same. So whatever number you put in for x or y or whatever your variable is, it has to make the two sides of the equation the same exact thing. Example 1, solving exponential equations with like bases. And it says solve each equation, check your solution. So on the first one, letter A, 3 to the power of x equals 81. So at this point, it's kind of like a guess and check scenario. If you were to do 3 to the power of 1, that's 3. 3 to the power of 2, that's 9. 3 to the third is 27. 3 to the fourth is 81, which is what we're trying to get to. So x equals 4 would be your answer. And then as for checking your solution, you kind of already did it. If you substitute 4 in, 3 to the fourth is 81. Letter B, 3 to what power equals 1 over 81? So keep in mind, when you raise something to a negative exponent, it means that you're really doing the reciprocal. So if I want 3 to become 1 over something, it means that my exponent's going to have to be negative. And I already know that 3 to the fourth power is positive 81. So if I do 3 to the negative fourth power, that would give me 1 over 81. So x this time is negative 4. Letter C, 7 to what power equals 7 to the fifth power? Well, let's think about this. 7 to some power equals 7 to the fifth power. Well, if I have 7 to the fifth power, this is telling me I need 5 sevens. Well, in order to keep it the same or equal, I would have to have 7 to the fifth power equals 7 to the fifth power. So x equals 5. Letter D, 2 to the 2x power equals 2 to the sixth. So let's think about this. 2 to the 2x equals 2 to the sixth. Well, over here I have 6 2's, which means over here I have to have 6 2's. Well, what would you have to put in for x in order to get 6 2's? And if you can do that in your head, great. But really what you're doing is you're taking the exponents of 2x and 6, and we're making another equation that says 2x has to be 6. Then we would divide by 2 and get x equals 3. And if we were to check that, I would substitute 3 right here. That would give me 2 to the 2 times 3 equals 2 to the sixth. Well, 2 to the 2 times 3 is really 2 to the sixth equals 2 to the sixth, and it does. Letter E, 5 to the 2x equals 5 to the x plus 1. So if we have the same base, that means we need the same exponent. So really the equation we want to solve here is 2x equals x plus 1. I'm going to subtract x. That gives me x equals 1. If we check that, it would be 5 to the power of 2 times 1 equals 5 to the power of 1 plus 1. 2 times 1 is 2. 1 plus 1 is 2. 5 squared does equal 5 squared, so x is 1. Letter F, 7 to the power of 3x plus 5 equals 7 to the power of x plus 1. Again, notice that we have the same bases. If the bases are the same, again, that means that the exponents have to be the same. So I'm going to set up that 3x plus 5 has to be the same as x plus 1. If we solve this, I'm going to subtract x. 2x plus 5 equals 1. Then I'm going to subtract 5. 2x equals negative 4. Then I'm going to divide by 2. X equals negative 2. If we check that, I'm going to have 7 to the power of 3 times negative 2 plus 5 equals 7 to the power of negative 2 plus 1. 3 times negative 2 is negative 6, plus 5 is negative 1. Negative 2 plus 1 is negative 1, and 7 to the negative 1 equals 7 to the negative 1. So our answer is x equals negative 2.